Hello everyone and welcome back to another STEM Helps video. Today we'll be talking about two-dimensional motion. So first we'll be talking about what a scalar and a vector quantity is. So what is a scalar quantity? Well, anything that has magnitude. For example, I had an example, speed or time. And when I say this, let's say we have a car that's going 60 miles per hour, or if you're in any place other than the United States, 60 kilometers per hour. And so when that happens, you don't know where I'm going, but you know that I'm going some magnitude. Now a vector we don't usually see in real life. We could, but it's just not common. Usually we just have direction. Like if you want directions, you won't ask how fast am I supposed to go during that time. Like you say, oh, I go 2 blocks north, but no one tells you you're supposed to go at 2 miles per hour. So a vector quantity has direction. And so the three main topics that we learn in physics is velocity, displacement, velocity, and acceleration. And usually we'll be talking about vectors. Scalar quantities are just an FYI, but vector quantity is what we need to talk about. And hopefully you understand that you can differentiate between the two. So now what we're going to do is we're going to draw a vector quantity. Now, usually we have numbers associated with this, but just so people get the idea of what a vector quantity is, I'm not going to have units. So let's say we have a soccer ball. Here, let's just have a normal ball, because I cannot draw a soccer ball. Alright, we have a normal ball, and I use my foot, and I kick it. I kick it in this direction, like this. So the distance is going to be our magnitude, over here, magnitude, and northeast is the direction. So I kick this ball northeast at some amount of force. I'm not going to tell you because this is just to give you a general idea of vectors. And so where do you think the ball will go? So intuition says that it will go, here, let's have a different color. It will go somewhere in this direction. And it'll, here, let me draw a straight line instead of dotted lines. It will go in this direction, which is correct. So now we can take this problem and we can apply it somewhere else. Let's make this a tiny bit more complicated. Let's say I have the same ball. I kick it this direction, but my friend, who doesn't know how to play soccer, when I'm kicking the ball, he kicks it this way. I'm trying to make this as artistic as possible. I'm not very good at drawing. So here, where do you expect the ball to go? Well, it would be somewhere around. It would be somewhere around here, like this, just a bit bigger, like this. That's what we would expect. So how do we add these arrows? So I'll show you an easy way to do it. Let's take this example, right? Here, let me recreate this very quickly. So the best thing about vectors is as long as you keep the direction and magnitude relatively the same, and since this is a sketch, it doesn't have to be exact, I can put this arrow here, right? Have not changed the direction or anything. I can put it way over here. Hopefully this is correct. Come on, same magnitude, yes. Like this. So you can put the arrow wherever you want, just for convenience. I'm going to have these two arrows tip to tail, and I'll explain why I'm doing this. So let's rearrange this problem over here. Here, let's have this problem. This is going to be our problem. All right, and let's say we have this same arrow. That looks about right. And now we're going to add this arrow. Alright, hopefully I have the same magnitude. That looks about right. Same direction, same magnitude. So if you were to just copy and paste, this should be where it looks like. So now, the reason why I put tip to tail is this is called adding vectors, where you can put this wherever you want. That's why I put the first one wherever I want. Honestly, I could have tried the same thing, and I'll show you that it results to the same amount. So back to the example, you start from one vector, the head of one vector you put to the tail of another vector. Now to find, we estimated that it would go up like this. Let's see if it does. So to calculate where it actually is going, what you do is you draw a line from the tail all the way up to the tip. It's actually supposed to be like this. It's not supposed to be slanted. I'm just not very good at drawing. So the overall, we're correct. The overall should be above. And let's try another one. So this is just with the ball. The ball is supposed to be going. The ball is supposed to be here. If you're confused, so let's make it just 3 or 4 arrows. All right. So let's have one arrow here like this. Here, let me make this a bit bigger of an arrow. Like this. And then here, let me have a soccer ball here. And then let's say I have another one like this. And another one like this. And another one like this. And another one like this. Alright, so I'm gonna pick out of the random mini mini mo this one, right? Just doesn't matter which one it is. So let's see if I can draw it perfectly close enough. Right? Now tail to tip. Let's see if I can draw this. Tail to tip, same magnitude. Right? So this has the same direction. Direction matters. Alright, so now it's going to be straight across is the next one. Honestly, you could pick whatever, but I'm just going in order from down to up. It doesn't matter. So now, this one, and these are just rough sketches, and then finally this one. Right, so now tail to tip, tail to tip, tail to tip, and to find the final vector, we can just take from tip to tail. So it's a huge amount of force going this way. So this is the basics of vector addition, and like we talked about, vectors has direction and magnitude, so you can't just change this to, oh, I want it this way instead. So direction does matter, but in scalar quantities, you don't have direction. And I hope that's helpful.